Hello everyone, welcome back to the channel. Today we are going to solve this amazing question on the code forces called tracking segments, which is division 3e question. So question states that A consists of n zeros and you are also given a set of m not necessarily different segments, means they can be same. Then each segment is defined by two numbers as usual. Its left starting index and right ending index, and represents subarray of ALI to ARI. Then segment L comma R Li comma Ri is called beautiful if the number of ones on the segment is strictly greater than the number of zeros. So that is the definition of the beautiful segment. And we have also given queue changes, means queries, you can say that. For each change you are given a number x, which means that you must assign an element ax the value 1. You have to find the first change after which at least one of m given segments become beautiful, or report that none of them is beautiful after processing all the queue changes. Okay, so they give index x, and if we find at index x there is 0, we should toggle it to 1. And what is the minimum operations after which at least one of those n segments become beautiful? So which means it has strictly greater number of ones than zeros. So let us take example at some sample test cases. So I have took this first test case and fourth test case to demonstrate how the algorithm works. First test case and the fourth one. So answer should be 3 and 3. So let's head here. Answer should be 3 and 3. So looking at here, everything at the start is 0, so we start processing the queries. So we toggle a 0 to 1 at index 5, then check if any of the segment is beautiful. It is not by now, at least. So after which we toggle the index 3 as 1. Again we check for all the subsegments or segments, not subsegments, segments. If any of them have strictly greater ones than zeros, so it is not the case. Then we toggle 1. Then we check that this segment 1 to 3, this segment 1 to 3 has two ones and one zero. So after the third change, one of the segment, at least one of the segments becomes beautiful. So our answer is 3. Similarly here, start processing the queries. First you toggle the index, the 0 at the index 4 as 1, then at 1 still any of the segment is not beautiful, but when you toggle this 2 as 1, this segment 1 to 3 becomes the beautiful because it has two ones and only one zero. So in this case also our answer is 3. So to solve this question I can use binary search. Why binary search? Because if at suppose kth operation, after kth operation my one of the segments become beautiful, okay, and it cannot happen that after the k plus 1th change any of my segment becomes not beautiful, right? So this hints us about the binary search, okay? So that's why binary search. So we will start applying binary search on the number of queries that needs to be executed before we arrive at the answer, okay? So to do that, let us see here. So here input is completed. So At most operations needed is q, means we can do is q, then minimum number of operations is 1, and initializing answer to -1. I will tell why this temp answer is there. First of all, let us begin with our binary search process. So when left is less than or equal to right, string str is equal to, so this is our basically the string of the zeros, and which will be made of n zeros. Then mid is equal to left plus right by 2, and starting to execute the queries, so toggling the ones wherever it is mentioned to, then prefix sums. So what prefix sum does is that checks if the number of ones in the segment is strictly greater than 1 or not. So calculating this prefix sums, whenever I encounter 1, I add 1 to the prefix sum, and whenever I encounter 0, I just assign it to the previous value and negate it by 1, because we have to decrease it when it is 1. So these are some nice debugging steps that I've added for your clarity. You can remove the comments and checks, not remove, just toggle them to the real statements in the code and check how the code works. So next, I'm checking if any of the segments, every m of the segment, means for every m of the segments I is equal to 0 to I less than m, I'm checking if any one of them is beautiful or not. So this is the edge case where first index is less than 0. So, and if it is not less than 0, prefix sum of v of I dot second minus 1 minus prefix sum of v of I dot first minus 2. This minus 2 I hope you all know. If you don't know, let me know in the comments, I'll explain there. So is greater than 0, then temp answer is equal to mid, means we are able to do at least one of the segments of those m segments as beautiful. So we break similar cases with here. Then if temp answer is equal to -1, still if it is -1, then we know that any of the m segments is not beautiful yet. So we increase left to mid plus 1, or if any one of these m segments become beautiful, so we decrease the right and update our answer as temp answer. And finally, when after we break this while loop, while left is less than or equal to right, we are remaining with our answer, so we simply output it. And what this temp answer does is that, let me explain you. So what this temp answer does is that you can look at this test case where n is equal to 5, m is equal to 5, and the segments are like 1 5 2 4 1 5 1 5 and 1 4. I encourage you to copy this code and run it after removing this temp answer thing, and means toggling comments to the statements of the code. I encourage you to check what happens if temp answer is not there on this specific test case. On this test case, you will get what temp answer makes the difference. Okay, so slight hint is that if suppose our actual answer is suppose 2, and our left is 1 at the beginning, and the number of queries is equal to right is equal to suppose 11. So firstly mid will be 11 plus 1 by 2, which is 6, which will also be the answer if we check because 6 is greater than 2. But if we make answer is equal to 6, then it will never go here. It will, suppose here in place of temp answer it was answer, then it will never go here left is equal to mid plus 1, right? Because answer will not be -1 anymore after where answer is equal to mid will be assigned. Okay, so that's why temp answer is included. I encourage you to copy paste this code into some editor or something like that, and check what these commented blocks were doing and how the dynamics of code are working. So that was it for today. This was the nice problem I saw on the Codeforces related to this binary search thing. So I thought it would be nice to cover it on my channel. I hope you enjoyed the solution, and for more such Codeforces problem, in fact for daily Codeforces problem and interesting solutions, stay tuned with our channel. Thank you for watching. Stay tuned. See you on the board again. Like the video, subscribe the channel. Okay, bye.